Hello, thank you for the introduction. We are happy to show you our vehicle thermal model that we built in GT Suite. I am Hlavecek from Skoda Auto.
And I'm Jan Fiala from Akka, Czech Republic.
What was our initial motivation? Of course, we had a 1G simulation of a cooling system before. However, we wanted to include dynamic drives in our simulation, and we wanted to focus in more detail in our underhood flow and heat transfer on cooling packet. When we were building the model, we included all the interacting systems that supplement the system with energy. We built a lot of them with the biggest focus on the coolant loop and the detailed underhood packet. The driver controls the vehicle and air conditioning is connected to the cabin. What are the benefits of having a GT simulation compared to a real test drive? We can modify everything very easily, the drive regime itself or all the boundary conditions, most importantly the ambient temperature. We can modify the control strategy, and we don't have any problems with the sensors. We don't have a limited number of them, and we can avoid sensor failures. Also, and that's very important, we can create a digital prototype before the actual vehicle is built. Also, and that's very clear, we save a lot of money and time performing the actual tests in the wind tunnel or on the road. However, to build the model itself, we need initially a lot of measurements for each component. To build such a complex model, we needed to combine a lot of data sources. We needed to put together data from the vehicle measurement, from the wind tunnel, or from the road. We needed to run a lot of CFD simulations of each individual component with a focus on the underhood. And we also needed to measure components separately. Some data we also got from the supplier.
During the model development, we faced several modeling challenges. One of them was the evaluation of the heat rejection map from the brake measurements, where we had to include also the thermal losses in the underhood area. Another one was the complex modeling of complex coolant loop with the secondary electric pump and gearbox cooling and the electronic thermostatic valve. And next one was the detailed underhood packet, how to model it, how to calibrate it to 3D results, how to include all the leakages, mask and grill. And at last you need also a proper engine load and proper heat rejection. So you need to simulate all the mechanical losses in the powertrain and also other losses on the vehicle. The coolant loop, as it is complex, was measured with many sensors. We built up the 1D model using the GEM3D to convert all the 3D pipes to 1D model. Here you can see the detailed coolant loop. In the green area is the engine thermal model, and here you can see that electronic control valve which extends the thermostat function. Now a little bit more about this electronic valve called Drehschieber. This extends the thermostatic valve function as it enables the fast heat up of the engine and reduces emissions. This engine is specific as it has cooled exhaust channels. This control valve can be controlled as a set point. You can use temperature or flow. Depends on you. In the real car, it's controlled for the temperature.
In the model, we used quite detailed engine modeling with 5 thermal masses connected to each other and also connected to the oil and coolant loop. We also had a turbocharger included. The heat rejection map was transferred to GT Suite from the brake measurements. We calibrated the motor itself to jacket convention and conduction that were simulated in 3D.